Hello and welcome, folks. Today we're tackling another HackerRank problem. This one is called strange counter, and I'll be doing it in Python. So let's read it out. There is a strange counter. At the first second, it displays the number 3. Okay, each second, the number displayed by decrements by 1 unit until it reaches 1. The next second, the timer resets to 2 times the initial number for the prior cycle and continues counting down. The diagram shows the counter values for each time t in the first 3 cycles. Okay, this sounds complicated, but I think it kind of makes sense here. So the time is always going up. So it's 1, 2, 3. But the value that you start with is going down 3, 2, 1. And then for the next round, you start, well, now you're at time 4, but you're starting at 2 times the initial value, which was 3, so now it's 6. And 6 is counting down to 1. And the time will be 9 by the value being 1, and then you start again now at 6 times 2, which is 12, but time is 10, and you go down to 21, and so it'll just keep going there. Okay, that kind of makes sense. Find and print the value displayed by the counter at time t. So I guess t is parameter, okay? But okay, so you're given an integer t for the time. Oh, and it starts with 3 always, I guess. Oh, okay, so I thought that would be a parameter, but it's not. It's always 3. Oh, interesting, okay. So one thing I'm also considering here is like these constraints here, because t could be very large, like 10 to the 12th power, and doing this in some kind of looping fashion might be really inefficient. So I don't think it makes sense to like literally go one iteration at a time, but to do like sort of batches, or to maybe there's a way we can use some kind of fancy math equation to just like solve for this. I'm not really good at math, so I don't know how I would do that. Okay. Usually for this kind of thing, any kind of like math stuff, I want to look for patterns. So I think the first thing I want to do is just sort of like get a sense of what this like sort of doubling thing looks like, because if there's a way we can sort of cheat out some kind of math, then we can short circuit or sort of take a shortcut to get to the answer. So the first value is always going to be 3, and then it'll be 6, 12, and this is just 3 times 2 to the 0. Oh, because I'm missing the 3, that's why. So this is 3. That's what it should be. So the 1, the 2 to the 3 to the 4, right? So 2 to the 1 is times 2 times 4. 3 times 4 is 12. Yeah, so this is yeah, this makes sense. Okay, so we can sort of do iterations of each of these sort of groupings using this pattern. And maybe there's a shorter way of doing it, but I think that's how I would do it. I would sort of like take this t time, and this time I could do like a running total. So the total here would be obviously 3 at this point, right? If you're done with that, you're at 3. Then this would be 9, and 21, and so on, right? So that would be we would remove that from t, because we're given t. That's the one thing we're given. So we sort of do one step, and we see what's left over, or I guess what the max is. This is like the remainder for each next step. Okay, I think I have an understanding of what's gonna happen here. So okay, so I want to keep. Okay, so I'm gonna keep running time, and the value, or I should say the max value, we iterate for each max value. So the max val equals 3 to begin with, because it's always 3. This is never changing. Keeping running time t, which is t. It's already. I'm just gonna keep it as t. I mean, I should call it like running t, maybe. I don't know. Like setting a variable to itself. And now we have to check, is the running t less than the current max value? I want to call it current max value. So while the running t is greater than the current max value, then we know we need to iterate. because there's still room. There's still a group to skip. A whole group of current max val to skip. And then all you have to do is subtract the current value from the running t minus max value, current max val. And we need to we just need to double the current value, which is easy because we could just do that times 2, right? I think that works. And then what happens after that here? I want to do like a little print statement here. Okay, perfect. So before it was running t is 4 and the current max was 3. Then we subtracted it, and then we're now at this state. So we get to a point where the current max is now greater than t, and now we can just do our sort of counting or our iteration. Oh, here's another case where we have 17 and we expected a 5. Okay, how did we get to 5? So it looks like it ran once. Yes, okay, 17, there was enough, so we subtracted 3, we got 14. And the next max was 6, perfect, and then that ran. And then we subtracted 6 from that 14, so we're at the new sort of level, which is at the current max is 12, and we have 8 left over. So I'm going to go up to our picture here because that's probably helpful here. So we're now on this third max value, which is 12. And then we do 8 down. So it's 1, 2, 3, 4, 5, 6, 7, 8. And that's where the 7 would be a 5 at that point. Okay. So we need it to get to a 5 for this because of that, because we see that that's the expected output. The way we get there is we do some kind of subtraction here because it's not the max value, is it? Because it's not like 12 minus 8, but it's sort of like 13 minus 8. Is that how you do it? 13 minus 8 would give you 5. Hold on, let's see here. What about this? Would 7 minus 1 give you 6? Technically it would, yeah. So I think because the iteration here, because of how it gets iterated, you're supposed to stop at the 1. So you need to go like kind of 1 more than the max value, and then you subtract the running t to get the answer. So I think at this point, we would return the current max value plus 1, and then we subtract the running t. I think that's the answer. I think that'll give you what you were looking for. Looks like it's passing for these tests. Oh my goodness, did I just get it that quickly? Okay. Let's see. I'm going to remove these statements here because it's cleaner code. Let's submit some code. Let's see if it just works. It just works. Holy moly. Holy moly, man. I feel like this is one of those things where there was a time where I would have really struggled on this kind of problem. But because I've done this stuff so much and like I've gotten a better intuitive sense of like how to solve these problems. Like for example, like doing this step. I spent like a minute or two doing this, but I knew it was going to be worth it because as long as you understand like these kinds of patterns, it will help you speed up this process here. I didn't even need to go through this like subtask thing because that's what I normally would have done. I would have iterated through it one time at a time before and gotten this step and then would have struggled to get like the max constraints. But because now I have a better understanding of like how these things work, I knew to go after this like more efficient way of like kind of chunking it and like going through the whole group and just subtracting it out and keeping this like running t. Technically, I don't even need the running t, right? Because I could just this t value right here. I was mentioning this before. Like I don't technically need the running t. I could just use the t because it's like not changing. So I can like do like that. That should still work. And the max value is always 3. I'm trying to think of like how I can make it more efficient. Oh, here's a kind of clever thing. Because of powers of 2, there's this thing in binary where you can just sort of shift the bit over once to the left, and that will be like multiplying by 2. I forget how to do that how do you do that in Python? Python. Oh, look at that. Yeah, it's like this exactly. So, and I believe you can do that in place. So I believe this would work, like an equal sign. That would just work. It just works. That's so funny. Yeah, you're shifting the bit. So it's like slightly more efficient to shift the bit because it's like at the machine level, it's like just quicker to shift the bit over instead of like actually going through the complicated math of multiplying by some arbitrary number, in this case 2. Why do that when you could just shift the bit over? And that's the same thing. I guess technically I can do the +1 after because it's just math, right? Yeah, I think this is as efficient as I'm gonna make it, or I'm sure there's like ways of taking this while loop and like truncating it or something, but I think this is basically as efficient as I'm able to get it. All right, folks, if this is the kind of content you enjoy, please make sure to like, subscribe, do all the good things, and I'll see you next time.